Hey there, today we are going to be talking about synthesis and decomposition reactions. And if you are following along from Richardson High School, we are going to be on page 11 of your notes. So get to page 11 and follow along. The first type of reaction that we're going to talk about today is synthesis reactions. And we've already learned the general reaction is that chemical A and chemical B get together and form chemical AB. So synthesis is all about getting together, getting elements or compounds to get together to form only one product. That's kind of a big deal here, is that we have to only form one product. With the ones that we're going to be asking you to write, you're going to be forming simple ionic products, and you are going to have to remember to crisscross the ions. So a simple little example is, let's say that I was going to combine lithium and oxygen. Now, when we're looking at our plain elements that we're going to combine, what you need to ask yourself is, are these diatomic elements? Remember that our diatomic elements are H, N, O, F, Cl, Bri, or nothyl bride. So anytime you see one of these elements, they have to get a little subscript of 2 on them. And these are the only 7 elements that do that. So oxygen is one of them. So I'm going to put a 2 right there. Lithium does not get the 2. This is when they are written as separate elements. We are now going to combine them into an ionic compound. Well, to write an ionic compound, like we said here, you need to crisscross the ions. So lithium has a charge of +1 and oxygen has a charge of -2. We are going to crisscross the charges down, so 2 will go on the Li. And the 1 we know comes down but then doesn't need to be written, so we can simply write an O. All right, so now we need to balance this equation. You can start with either the lithium or the oxygen. On a simple equation like this, it's not going to matter. You'll get the answer either way. I'm going to start by balancing the oxygen. So oxygen ends with a 2, and so I need 2 oxygens on the product side as well. Remember that you have to write the subscripts in front of the compounds. That's your only option. So the 2 here distributes to both the Li2 and the O. So the lithium is not balanced now. The oxygen has 2 on each side, but the lithium does not. The lithium on the product side, I'm going to highlight it here, that's 4 lithiums. But on the reactant side, it's only 1. So I'm going to put a 4 in front of the lithium at the beginning, and that will balance this equation, and I will have 4 lithiums on both sides. So 4 and 4. So that is a balanced synthesis equation, and that's one of our goals for today. This is another example just to remind you that synthesis is not always an element plus an element. This is actually a compound, NH3, that's called ammonia, and another compound, HCl, is called hydrochloric acid, and it makes another bigger compound. So just a reminder that sometimes it's 2 elements combining, sometimes it's an element and a compound, and sometimes it's 2 compounds combining. There's a video that goes along with this, and if you open the slides from your teacher, you can watch it. We are going to try a few practice problems here, giving you a little hint on each element what its charge is. But I want you to remember that those charges only matter when we put the ions together, when we make the products. So it says, predict the products and write the balanced chemical equation for the following reactants. So my reactants here are aluminum and nitrogen. So I'm going to write their element symbols, and then I'm going to ask myself, which of these elements cannot be alone because it's diatomic? This is nitrogen. Aluminum does not need a 2, but nitrogen does. Okay, now I'm going to draw my arrow to write my product. I need to combine aluminum and nitrogen with their ion charges to write the product. Aluminum is +3 and nitrogen is -3. Well, that's nice. I see that the +3 and -3 are going to cancel, so my compound is going to be AlN. Final step is to ask myself if it's balanced. It's not. I started with 2 nitrogens and I need to end with 2 nitrogens. So I'm going to put a 2 in front of the nitrogen-containing substance. Aluminum, I now have 2 on the product side, and so I need 2 in front of the aluminum on the reactant side, and everything is now balanced. Looking good. Next up, lithium reacts with phosphorus. I'm going to start by writing down my element symbols, lithium and phosphorus. Ask yourself, do either of these need a 2 on them? No, they do not. These are not any of our 7 diatomic elements. Now I'm going to write my products. Lithium has a charge of +1, and phosphorus has a charge of -3. If I crisscross these charges, the 3 is going to come down on the lithium, so that will be Li3. The 1 on the lithium is going to come down to the phosphorus, and we don't need to write the 1, so Li3P. To balance this equation, the only thing I need to look at is the lithium. It started with 1 and it ended with 3. So I'm going to put a 3 in front of the lithium that we started with, and this equation is all done. Beautiful. All right, last one, calcium and iodine. Step 1, write down your elements. That looks a little crazy. I'm going to fix it. Calcium and iodine. All right, either of those elements need a 2 on them. The iodine does, because it's one of our H nautical diatomic elements. The calcium does not. Okay, to write these as a compound, I'm going to remember their charges. So off to the side, I'm going to think Ca plus 2, iodine minus 1. I'm going to crisscross those numbers down. So Ca is going to get a 1, which I don't need to write, and iodine is going to get a 2. Looking at this equation, I notice that it's already balanced. So I do a little dance, a little celebration. I don't have to balance it, and I am done. All right, good job, y'all. That is how we balance and write synthesis reactions for ionic compounds. That's as far as we're going to go in this class. In class, we're going to do a demonstration about magnesium burning in oxygen. Just to kind of give you an idea of what happened there, magnesium is the silver metal wire. We're going to burn it in a Bunsen burner, which is going to combine it with oxygen gas, which is diatomic, and they are going to combine into a single compound. Now, magnesium, when I combine it with oxygen, magnesium has a charge of +2, oxygen has a charge of -2, and those charges will cancel. So I will get MgO. Finally, this is not quite a balanced equation. I start with 2 oxygens here, so I need 2 oxygens here. And I now have 2 magnesiums on the product side. I need 2 magnesiums on the reactant side. There we go. That is our balanced equation. All right, next up, we're going to talk about decomposition reactions. Decomposition reactions are simply the opposite of synthesis. We take one big compound and it gets broken down into 2 smaller parts. Now, those 2 simpler substances might be elements or they might be compounds, either way. The main idea is that we started with only one reactant. If you have more than one reactant, it's not going to be decomposition. So, example that shows that one reactant breaks up into 2 different things is shown here. Now, this one's interesting because it shows that a compound could break up into a compound plus an element, and that's totally fine. It could break up into a compound and a compound, or like the ones we're going to look at today, it could break down into 2 elements. Again, there's a video here. If you want to watch the video, you can check out the Google Slides that your teacher shared with you. Okay, we're going to do a couple of examples here about writing the balanced equation for some decomposition reactions. So, to write these, we are going to be starting with a compound, and that means we need to crisscross the charges. Barium has a charge of +2, and oxide has a charge of -2. So that means when I write those ions together, their charges are going to cancel, and so I can simply write BaO. BaO is going to decompose into the two elements that we have. So that's going to be Ba and O for oxygen. Do either of those need a subscript of 2? Yes, oxygen does. Every time when it's by itself, it needs a 2 so that it's not alone. It's paired up with another oxygen. And so balancing this equation, barium is fine to start. Oxygen ends with 2, and so it needs to begin with 2. So I put a 2 in front of the oxygen substance. And now I have 2 bariums, and that's easy to fix with a 2 in front of the barium element. All right, let's try another one. We have aluminum fluoride. Aluminum fluoride is going to be AlF, but I need to work on the subscripts. Aluminum has a +3 charge. Fluoride has a -1 charge. So the 3 is going to go down on the fluorine, and the 1 is going to go down and be located on the aluminum, and we don't have to write the 1s. Okay, what is this going to decompose into? The two elements are going to be Al and F. Do either of those elements need a subscript of 2? Yes, the fluorine does. Now, to balance this one, we have what I call the 3-2 split, or the 3-2 switcheroo. Fluorine has 3 on one side and 2 on the other. So I'm going to swap them. I'm going to put a 2 in front of the fluorine-containing compound on the reactant side that had a 3, and I'm going to put a 3 in front of the fluorine that had a 2. Notice how I did a switcheroo on the 3-2. Finally, the aluminum has 2 on the reactant side, and so I'm going to put 2 on the product side. That works out. I have 2 aluminums and 6 fluorines on both sides of the reaction. 2 more. Lithium and chlorine. Okay, lithium chloride is going to be LiCl. If I think about their charges, I'm going to do that over here. Lithium has a charge of +1, and chloride has a charge of -1. That means that the charges cancel 1 and 1, and I can simply write LiCl. It's going to decompose, that means break apart, into Li and Cl. Which of these two elements on the product side needs a subscript of 2? It's chlorine. So chlorine gets a subscript of 2, and then I will need to put a 2 in front of the chlorine compound on the reactant side to balance the chlorines. Now chlorine is 2 and 2. Lithium starts with 2 on the reactant side. I need 2 on the product side, so I can put a 2 in front of the lithium, and that is now a beautiful balanced equation. Okay, one more to go through. Aluminum oxide decomposes during electrolysis. What we really need to focus on here is aluminum oxide decomposes during electrolysis. It's just telling you how, but it doesn't change how you write the balanced equation. Aluminum oxide. I'm going to think to myself ALO, but I need to do the charges. Aluminum has a charge of +3, and oxide has a charge of -2. So the 2 is going to come down on the aluminum, and the 3 is going to come down onto the oxygen. 3 oxygens. All right. Funny looking 3. It's going to decompose, that means an arrow, into aluminum, Al, and oxygen. When you write plain elements, you ask yourself, do either of these need a subscript? Yes, the oxygen does. It's going to get a 2 down there. Okay, oxygen has the 3-2, so I'm going to call it the 3-2 switcheroo. So the oxygen with a 3 is going to get a 2 out front of that substance, and the oxygen that has a 2 on it is going to get a 3 out front. That makes it 6 oxygens on both sides. Finally, aluminum, I have 2 and 2 on the aluminum over here on the reactant side, so that's 2 times 2, which is 4. And we have our final beautiful balanced equation. The final part of this lesson is a demonstration that we like to call elephant toothpaste. It's a little bit more complex than the equations that you need to be responsible for balancing, so we're not going to include it in this video here. All right, that is the end of our video. If you are at Richardson High School, your homework might be pages 25 through 26. If it is, please change number 11, change the Fe to zinc, and that'll make your life a little bit easier. I hope this was helpful. If you have any questions, please let your teacher know. We're happy to help you. Thanks for watching. Bye.